So we have to show that the derivative of y with respect to x is given by square root of x squared minus x e squared if y is given by this particular expression. So let's start with this expression. We'll begin by differentiating it. So we have derivative of y with respect to x, that's equals to, I'll take half as the constant, so I'll leave it out of the derivative. So that will be multiplied to derivative of x times square root of x squared minus a squared minus, so a here is a constant, so we have e squared over 2 times derivative of the logarithmic function. So here for the first derivative we need to apply the product rule. We'll treat x as the first function and square root of x squared minus e squared as the second function. So this should give us half. We have derivative of the first function multiplied to the second function plus the first function times derivative of the second function. So the second function can be also written as x squared minus a squared raised to the power of half. Means the same thing. Minus a squared over 2 times. So now we have to take the derivative of the logarithmic function. We know that derivative of the logarithmic function, that is 1 over x. So here, so we have 1 over x plus square root of x squared minus a squared. But we need to apply the chain rule. For that we need to multiply it to the derivative of the argument of the logarithmic function, which is x plus square root of x squared minus a squared. So we have half times the derivative of x with respect to x, so that's simply 1. So we have square root of x squared minus a squared plus x times, so let's apply the power rule here. So we have 1 over 2 times x squared minus a squared raised to the power of half minus 1, so that's negative half. But we have to apply the chain rule as well. So chain rule means taking the derivative of x squared minus a squared and multiplying it to this value. So derivative of x squared minus a squared, so that will be simply 2x minus, let's combine them. So we have a squared whole thing divided by 2 times x plus square root of x squared minus a squared. Now derivative of x with respect to x, so that's 1 plus derivative of square root of x squared minus a squared. So I'm leaving this as an exercise for you. Fine. So we have half times square root of x squared minus a squared. So this 2 and 2 goes away. X and x gets multiplied to give us x squared. And we'll take this term to the denominator. So that's simply square root of x squared minus a squared. Fine. Minus a squared. So we combine these two terms. So we have square root of x squared minus a squared plus x whole thing divided by square root of x squared minus a squared. So this term and this term factors out. And now we are left with square root of x squared minus a squared divided by 2 plus x squared divided by 2 times square root of x squared minus a squared minus a squared divided by 2 times square root of x squared minus a squared. Now we will combine the three terms. In the denominator we have 2 times square root of x squared minus a squared. Now in the numerator we will have x squared minus a squared plus x squared minus a squared. So let's combine them. So we have 2x squared minus 2a squared divided by 2 times square root of x squared minus a squared. And this can be also written as 2 times x squared minus a squared whole thing divided by 2 times x squared minus a squared. Or simply the 2 and 2 goes away and we have square root of x squared minus a squared. So this means dy over dx, that's equals to square root of x squared minus a squared. And this is what we are asked to prove. Let's verify it with the question that we have gotten the right expression. So here we have dy over dx equals to square root of x squared minus a squared, which is correct.